Hey class, this is again continuing with the learning, looking at exponential functions. So this is the work we did on the last video I created. So I know the one I assigned to you guys was a video that was already existing online. So this is continuing with this lesson on exponential functions and transformations of exponential functions. So the parameters a, h, and k. So I hope you had a chance to play around in Desmos and realize the effects that A has on the graph, H has on the graph, and K has on the graph. So this one we're just going to do two examples, and then I'll assign work based on this work. So I'll start with lesson 21-4. That's page 332. So 332. So the way they do it here is very straightforward. So um, the the way I would advise to do these functions is by breaking it down first. Again, recognizing like I'll put in quotes the parent function. So I'll start with B. So look at B. They're asking us to graph three functions. So uh, I'll just write them here. Uh, f of x is equal to 10x. Then we also have g of x, which is equals 10x to the power x minus 1, and then h of x, which is equal to 10 to the power of x plus 3. So your job is this. Recognize if what's given is the parameter a, h, or k. So if you don't see it, kind of what we did with the other functions, write it right on top of it. So a times b to the x minus h power plus k. So notice that all of these, I recognize that a is this number in front, it's an invisible 1. So 1 times 10 to the x power. So because it's 1 doesn't have any effect on that. And the way this is set up, I can see that here, where I'm supposed to see an h is 0. And where I'm supposed to see a k, it's also 0. So let me do this to keep them separate. So here I know that a is equal to 1, h is equal to 0, and k is equal to 0. So if I do the same thing for this function, g of x is equal to a times b to the power of x minus h plus k. Again, if I compare the parameters, it will be consistent. A, the number that is in front of b, because I'm multiplying, I don't see it's an invisible 1. Here I see that h is negative 1, and then for k I don't see anything there, so it means that k has to be 0. So a is equal to 1. Here h is equal to negative 1, and k is equal to 0. So with that, you can look at the notes. We know that h makes the graph go left and right. So again, if you do to this one, you will recognize that again a is 1, h is 3, and k is 0. So then if you were to sketch this graph, we're going to call this one, and I said in quotes, the parent function. And if you did the work that I assigned previously, I said whenever you have to make a table, just keep it consistent. So I'm going to grab this function. So I'm going to make a table first. And just at least, I know if the Alex work asks for at least 5 values, so do the same thing if you want. F of x. So choose negative 2, negative 1, 0, 1, 2. So if I do the work for this one. So this would be, again, the function is f of x is equal to 10 to the x power. So this would be 10 to the negative second power, which is 1 over 100. This would be 10 to the negative 1 power, which is 1 over 10. This is 10 to the 0 power, which is equal to 1. This is 10 to the 1 power, which is just 10. And this is 10 to the second power, which is 100. So now I see what the graph looks like. So I'm going to use those points to sketch my graph. So I'm going to use it right here. I'm going to sketch it here. And again, I'm going to be as accurate as I can, x and y. So x goes to negative 1, negative 2, 1, and 2. And notice that the numbers, your y values, it's really small, small, 1, 10, it goes up really fast. So I'm just going to say just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So notice that based on my skill, I won't even be able to sketch most of my, at least 2,100. So I'll plug my points. So I'll plug negative 2,1 over 100. And if you don't have calculus, it's a really small number. So again, as closely as, so I'll say it's right there. So next one is negative 1,1 over 10. So again, it's also a small number. 0,1, it would be right here. 1,10, it would be right here. And then 2,100, I don't see it, but I see that my graph would be something like this. So I'm going to use my parent function to figure out this graph and then this graph. So I know that here in this graph, g of x, h is negative 1. So h makes the graph go left or right. And again, if we're adding, that means we're going to go to the right. And we're adding by 1, so I'm just going to go move right once. So then I will just grab all my points and move it to the right one time. So I'll use a different color for that. Then I'll move this point, it will be right here, and right here. So my graph would look like this. Let me use a different color. So that's my g of x. This is my graph f of x. And then if I want to grab h of x, so again, recognize the parameter. So that's h. H is positive, so that means it's going to move graph 3 units left. So that means I'm going to go to f of x, my parent function. Again, this is what we call it, a parent function. I'm going to move every point 3 times to the left. So if I do that, let me use orange for this one. So if I move this point 3 times to the left, it will be right here. It will go from 1 to negative 2. So if I move this point 3 times to the left, it would be at negative 3, and then so on. Then I see that my graph would be something like this. So notice that, and again, that's because of the parameter here is h. If you look at this example A, um, start by sketching this graph, and then based on that, recognize what this is telling you to do, and then once you have the parent function, recognize what this is telling you to do. In this one, so again, my approach would be much as this: graph this one first. Again, choose the same values if you want: -2, -1, 0, 1, 2. Make the table sketch that. That's what we call the parent function. And then recognize the parameter. Is this A, H, and K? Is this A, H, and K? And then what's going to happen? If it's going to bring everything to the left or to the right, up or down, and then keep the form. So we're going to do one example where it's not broken out like this, but we're going to use the same approach. So on the next page, we're going to sketch this one. So let me rewrite it here. So if you want to try this first, and then pause the video, and then you can check the work later. So the telling us that g of x is equal to 3 to the power of x plus 4 plus 1. So I'm going to write the general form: a times b to the power of x minus h plus k. And again, compare the functions. A is the number right here. If we don't see that, what number is that? So it's an invisible 1. Got to put this in parentheses just to be consistent. Then I see that this is h. And then lastly, I see that this is k. So I know that k is equal to 1, so nothing happens in that, so it doesn't change the graph. Oops, doesn't change graph. I see that h is equal to plus 4, so move graph 4 units to the left. Remember, if we're adding, move to the left. If we're subtracting, move to the right. Notice that k is equal to 1. So move graph 1 unit up. So now I know the transformation. So this is what I'm going to do. I'm going to graph again my parent function, which is y equals 3 to the x power. And again, I get it from just by looking at b and x. So again, where do I get the parent function from? Just by looking at y is equal b to the x power. And I'm going to do my graph. Like I said, keep it simple. X and y, -2, -1, 0, 1, 2, and simply plug it in. So we plug in -2, this becomes 3 to a negative second power, which is 1 over 9. This is the same thing as 3 to the -1 power, which is the same thing as 1 over 3. 3 to the 0 power, which is equals to 1. 3 to the first power, which is just 3. And 3 to the second power, which equals 9. So now I got my 5 points. So I'm going to sketch my graph. So again, notice that you might not have enough points, which is okay. I know in the Alex work, they only ask you for 5 points at least. So -2 comma, I'm going to start with -2 comma 1 over 9. So if you do that in a calculator, and then we just double check so we can, because you do it, you want to double check, verify with me. So 1 divided by 9 is 1.111. 1. So I'm going to say, okay, so it's going to be somewhere here. So now with that, so next point is -1, 1 over 3, and if you do the negative, it's 0.333. So okay, let's approximate as best as I can. When x is 0, y is 1, so 0, 1. When x is 1, y is 3, which is right here. And the last one, when x is 2, y is 9, which is doesn't show, so I'm going to approximate somewhere here. So there's my parent function. So I'm going to start with sketching my parent function. So this work should be very familiar to how we did transformations of, the parabola and absolute value functions. Remember, like I would ask you to sketch the parent function and, sorry, let's get this right. Sketch the parent function and then use that to sketch the next function. So there it is. So I know that that's the parent function, but the original tells me this was my original function, so I know this is what's happening. I need to move the graph 4 units to the left and 1 up. So I'm going to use each point, and I'm going to move it again 4 units to the left, 1, 2, 3, 4, and 1 up. So there's my new point. Same thing to this one. 1, 2, 3, 4, and 1 up. Oops. All right. So, all right. So it's okay. Just close it. And we'll see where we left off. Okay, no big deal. So 4 units to the left, 1, 2, 3, 4, and 1 to the right. Same thing to this one. 1, 2, 3, 4, and 1 this way. And same thing to this one. 1, 2, 3, 4, and 1 right here. So my new points would be here, 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 and here. So I will do the same thing to this one. 4 to the right, and 1 up. 1, 2, 3, 4, and 1 up. So again, I'm approximating it. So then now I can sketch my graph. So notice that it would be something like this. So there's my graph. So again, look at the this example so that you can do the work for the rest of the graphs. If you need to check your work, you can use decimals. But this is my advice. Before you do the work, recognize your, again in quotes, parent function, and then recognize your A, H, and K, and how is that going to affect the graph. And when you make the table, keep it consistent. If you want to use the same values, -2, -1, 0, 1, and 2, that's fine. And then simply follow the, what each parameter is asking you to do. Are you going to move it left? Are you going to move it right? How many times? Are you going to move it up? Are you going to move it down? And how many times? So again, if you have any questions, send me those messages. I see that some of you are submitting work. If I haven't graded your work, just be patient. I will grade it, as soon as I get to the work. And make sure you do the work that goes with this video. So again, stay safe and feel free to email me if you have any questions.